Hello YouTube. I just want to put a video on here with my latest project. This is a solar power generator, and I want to first give thanks to a lot of people who have put videos of their projects for solar power generators on, because it gave me the idea. You see, this is a Husky case that I got at Home Depot, and if we go to the end of the unit down here on this end, these are where my AC outlets are, and you can see here I have two Leviton 15 amp 120 volt AC outlets. They have the Tamac weather resistant covers on them that you can pull up, and they are GFCI protected. And there's two here, and you've got two over here as well. In the middle here is a Noco Genius AC port plug that I got on Amazon.com. This is where you bring your shore power in and plug your 120 volt AC right into here, and this will provide a charge for the batteries from shore power. It also has the weather resistant plug on it. Now on this end of the case, I have my DC components, my DC outlets. Right here you're going to see two 12 volt cigarette lighter sockets. They're marine grade sockets that have the weather resistant cover. I have two of those here, and then right next to them here I have two USB ports and another two USB ports here. And then right here I have two sets of Anderson power pole connectors that I use for my ham radio gear. And all of these have the weather resistant covers on them. I also didn't want to have DC power come to all of these at once, so I put these dual pole single throw, the DSPT rocker switches on here to turn each of the circuits on here separately. The two circuits here with the Anderson power poles is controlled by this one. These two circuits controlled by this DPST rocker switch. Here in the middle I have the emergency battery cutoff switch that will isolate the battery in case of some sort of problem inside here. Also right here I have two through panel battery connectors. These are the negative and positive 3/8 studs connectors, and they have the 18 thread per inch pattern here. Got those on Amazon.com. These particular knobs here were very difficult to find. I wanted these particular knobs. They're made by KIP, a company called KIP, K-I-P-P. And I found these at fixtureworks.com, and I really like these compared to all of the ones that I have seen. But fixtureworks.com allows you to order these in smaller quantities. Now, moving around to the back of the case here, right here is the connector. It's a Deltran connector, female connector. And this is where the solar will come in, from the solar panels. This Deltran connector is made by Battery Tender, and you can either get this at batterytender.com or it also sells on Amazon. And the wires coming in from the solar panels are 6 gauge wire. It's welding wire, and it comes to the male part of the connector here and plugs right into the side here, and you turn this and it will pull it in until it clicks, and you've got a solid connection there. And that's the solar coming in. I have two fans on the case. This fan right here is an output fan. I have an intake fan on the front of the case. These fans are from Amazon.com. They are Scythe Slipstream 120 millimeter 3-pin fans, both running at 1900 RPM. The intake fan on the front has a filter to try to keep the contents inside as clean as possible. And here on the front of the case is the intake fan I was talking about. Now both of these fans have 120 millimeter louvered fan guards on them. This was another difficult item for me to find, the ones that I wanted, and I was able to get these louvered fan guards on digikey.com. Now opening the case, you can see that my panel here on top, this panel is about 3/16 of an inch thick. It's blackboard material that I actually picked up at Home Depot, and I measured and was able to cut it to fit perfectly in here and make it to where we could keep the inside as clean as possible. The two handles on each end, these black handles, I actually had to pick up at Lowe's. Home Depot only sold the white ones. My local Home Depot did. You can see also 3 remotes basically that I've cut into the panel. The one on the far right here is made by Bayite. It's a 12 volt DC Fahrenheit digital temperature controller. I just picked that up on Amazon.com. The middle one is Magnum Energy's MERC50 remote inverter charger controller, and this controls the inverter charger that's inside. We'll see here in a minute. And I won't go into how these work because there's other videos on YouTube that tell you how these remotes work. And then the one on the far left is the remote for the Fangpusen charge controller, the solar charge controller that we'll see when we get inside. Now moving to the inside of the box to see where all the components are. We've got here, I have 2 102 amp hour AGM batteries. Picked up both of these batteries used. They were actually emergency backup power for a data center. I paid $50 a piece for them, I thought, which was a pretty good deal. Each battery is about 75 pounds each, which that alone is 150 pounds here to this box. As you can see, I have them wired in parallel to increase the capacity so I get the full 200 amp hours out of this 12 volt system. And I put them in plastic battery boxes from Walmart that I bolted to the bottom of the case. All 12 volt DC connectors receive power from the batteries via this Blue Sea Systems ST Blade fuse block. The load wire providing current from the batteries to the fuse block is protected with this 100 amp inline fuse here, and the fuse block is rated itself at 100 amps, and it protects 12 circuits coming in here. If I take this off, you could probably see it a lot better if I remove the cover, and there you can see the DC circuits that are coming in there, and it'll handle up to 12. This right here is the solar inlet that we talked about earlier, coming in from the solar panels. It comes over here to the Fangpusen solar charge controller. This is a 100 volt 50 amp charge controller, and for the most part could probably handle about 7 100 watt solar panels. When you consider the line loss that you're going to get coming from the solar panels, and the fact that they're only going to put out about 100 watts in full sunlight, direct sunlight, you could handle probably about 7 100 watt panels on this thing. And so this will charge the batteries with the solar panels. Now moving over here to the inverter charger, this is a Magnum Energy ME 2012 modified sine wave inverter and a 100 amp battery charger. And the nice thing about this charger is that it does have 2 AC outlets that you can see here that allows me to have the 2 separate AC plugs down there at the end. This particular inverter is protected here with a 300 amp inline fuse. And I also have the ME-BMK, the Magnum Energy ME battery monitor kit installed. You can see here the shunt and also the things that are needed to show me the state of charge of my batteries. And this is my latest project. It's been really fun. We've had it out camping, and it's been great. Thanks to everybody for the tips to help me with my project.